Hey class, we're back. Let's keep going with graph theory. So from your cover sheet here, click on the notes. I've already got them open. And we're going to start with a walk around the neighborhood. Now, two vertices are adjacent if they're connected by an edge, and edges are considered adjacent if they share a vertex. Like we said at the end of the last video, the degree of a vertex is the number of edges. If you're using the booklet, replace vertices with edges, connecting to the vertex. So if the degree of the vertex is even, we say it's a vertex of even degree, or we might just say it's even. If the degree of a vertex is odd, then we say it's a vertex of odd degree, or we might just say it's odd. So the neighborhood of a vertex is the subset of vertices in the graph that are adjacent to the vertex. And we name it like this, N of A, or the neighborhood of A. Let's take a look at that. So here, for A, I have 1, 2, 3, 4 edges connecting to A, so it has degree 4. Looking at E, 1, 2, 3 edges connect to E. That should say E. So 3 edges connect to E, and so E has degree 3. If you look at F, there are no edges connecting to F, and so it has degree 0. Looking at G, now G has 2 connections. It has a connection from the top and a connection from the bottom. So it does have degree 2. 2 edge ends connect to G. So the neighborhood of A is going to be all of the adjacent vertices. So B, C, D, and E are in the neighborhood of A. For the neighborhood of E, it's A and D. We don't need to list D twice, it just connects twice. All right, the neighborhood of F is the empty set. We're not going to put 0. We put either the empty set or the null sign. And the neighborhood of G is just G because it connects to itself. All right, so here you look, A has degree 2 and has neighborhood B and D. B connects to A, C, and F and has a degree of 3. C has degree 3, but its neighborhood is just B and D. CD has that double connection there. D has a degree of 4, and its neighborhood is ACF. E has a degree of 0, and its neighborhood is an empty set because nothing connects to E. And F has a degree of 4. 1, 2, 3, 4. And its neighborhood is BDF. It connects to itself. All right, so let's talk about paths and circuits now. A path is a sequence of vertices where each vertex is adjacent to the next, and an edge can only be traveled once. The path length is the number of edges in that path. And a circuit is a path that starts and stops at the same vertex. Let's take a look. Here, when finding that path from A to D, I travel from A to B to D. And then I write A, B, D. Now, is that the only path from A to D? Of course not. You could go A to B this way and then to D. Or you could take longer, A to B to C to D. Or you could go A to B up the straight edge and then circle back to A on the looped edge and then go up to C and then go back to B and then loop down to D. As long as you are only traveling an edge once, you're making a path. So is CBABC a path? Let's look. C, B, A, B, To get back to C, I've got to travel that path again. So no, that's not a path. It would travel BC twice. What about all paths of length 2 from E? That means it can have 2 edges. All right. E to D to C is a path of length 2. E to D to B is a path of length 2. And there's no other paths from E of length 2. Now here, let's find a circuit from D. So here, I went from D to B to A to L to D. Is that the only circuit? Of course not. I could have gone D to B to A this way, to L this way, and then back to D. Or I could have gone the other direction, D to L to A to B to D. What matters is that I have a path that ends where it begins and that it only touches an edge once. Now, let's find a length 2 circuit from A. So it's got to end where it starts, and it can only cross or travel across 2 edges. So I can go A to L to A, that's length 2, or I could go from A to B to A. It's another circuit of length 2. Now, Euler paths are paths that visit each side, every side in the graph, exactly once. And an Euler circuit is a circuit that visits each side exactly once. So it's an Euler path that ends where it begins. Now, you absolutely cannot retrace your steps or use the same edge twice when looking for Euler paths and circuits. It just does not work. So here, do I have an Euler path? Yeah, I do. If I start at B, I can go to D to E to A to B to A to E, and I've traveled every edge and I haven't retraced any edges. So yeah, there's an Euler path. But is there an Euler circuit? No. There's no way for me to get back to where I started without crossing over edges that I've already crossed. There's got to be a rule about that. I'll bet you we're going to learn that later. But for now, we're going to stop and we're going to pop back over to our cover sheet and we're going to go to practice set 2, which will open up. Okay, so you have 1, 2, 3, 4, not sure what's going on there, 5, 6 problems to do. Let me know if you have any trouble. Good luck.